Hi everyone. In this tutorial I wanted to show you how to model this shape. This is a twisted tetrahedron. I wanted to get in this quick tutorial before the holidays, and this seemed like a good shape to attack in a tutorial. So basically what we'll do is we'll model this, and we'll model it to scale so that it could be used as either a 3D print or perhaps even a digital asset of some kind. This would make a good pendant or something you can string a chain through, or whatever, even an earring or something like that for a character, or as an actual 3D print. Alright, so we'll do this tutorial in 3dsmax. The first thing we'll do is, since we're modeling to scale, we'll want to make sure that our units are set. I've set mine to millimeters, and the way to do that is to go here to Unit Setup. I've chosen millimeters as the display unit, but also make sure that your system unit setup is set to the same. So millimeters, 1 unit equals 1 millimeter here. Alright, so we're all set to go for modeling to real-world scale. Okay, now the first thing we'll do is we'll go ahead to Extended Primitives, and we'll bring up the Hydra primitive. Alright, and we'll extend it to a radius of 40 millimeters. Okay, and we'll keep it in the Tetra family, but we'll change the family parameters. The P parameter will adjust to 0.7, and then the Q parameter will be 0.3. Alright, so we end up with this shape. Alright, and the first thing I'll do is tap J on the keyboard to get rid of the bounding box selection, and tap F4 to bring up your edged faces. Okay, so now in the command panel I'll add an edit poly modifier on top of that. Alright, and we'll switch to face level. Alright, and select one of these large triangular faces, and then up here in the Graphite Modeling ribbon in the Modify selection, select Similar to grab them all. Okay, and just go ahead and delete those. Alright, so now we're left with this. Alright, so now we'll grab the smaller triangle. Alright, and we'll go ahead and select Similar to grab them all. Alright, now we'll go up here to our reference coordinate system, and we'll change that to local. Alright, and actually we got to switch to our scale gizmo first, and then we'll switch to local up here. Alright, and we're going to go ahead and scale this down by about 60%. Alright, so down there in the coordinate panel down there, you can see where your absolute transform coordinate readouts down here. You could just watch that until it hits 60. Alright, and that's what I did there. You can hold Control, and it'll reduce in increments of 1 degree. Alright, so I've reduced it to 60%, and the next step is to go ahead and add a shell modifier. Okay, and we'll do an inner amount to about 10 millimeters. Alright, so about like that. And actually we may be able to go even further than that. Let's see. Yeah, I think 10 is good, so I'll keep it at 10. Alright, but you can see what happens here now when you do it, when you apply the shell. The inner amount of the shell, it does what it's supposed to do, but the more that you increase the amount, you can see that these inner parts here begin to close in on themselves. So if we had, let's adjust it down to 15 millimeters, and you can see that we have very thin faces in here. All right, so at 15 millimeters, we could fix that. What we want to do is go ahead and apply an edit poly on top of that. All right, and then on the interior, select one of those triangles. Select similar to grab them all. Tap F3 to go into wireframe. Tap T to go in top view. All right, and with your local transform coordinates set, you can go ahead and scale that up until you've matched the outer edges of the model, just like that. All right, now what that's done is it's transformed those inner faces to the same area width of the outer faces. Okay, so now they're equal in area, surface area. All right, so tapping P to go back into perspective mode here. All right, so this is the objective that I was looking to achieve. So we put our shell at 15 inner amount, and we just scaled those out to be equivalent to the outer faces in area. All right, so once we've done that, we can go ahead into our edge mode, select one of these long edges here, all right, along one of these flanks, and then let's see, tap hold on your Alt key while tapping the R key to ring select that entire group of edges. All right, then go ahead into your select similar again to grab them all. All right, and hold down Shift while you click Connect up here in the graphite ribbon, and that will bring up the caddy. All right, so that we can adjust some segments and different parameters here. So in the Connect caddy, we'll adjust it to 2 segments, and then we'll go ahead and pinch that to about, let's say, about 70%, I think. Yeah, 70%. All right, so 2 segments, we'll pinch them 70%, and just click the check mark for OK to accept that. Okay. Now, with those edges still selected, hold down Shift and switch to your face mode, and that will select all of the faces in between those newly inserted edge loops. All right, and we can go ahead and delete that. All right, so that leaves us with this. Now, if we switch over to border, all of the borders here on these open faces will be selected. If they're not, just go ahead and select them all, and just cap them. All right, so this is where we're at. All right, so now we're going to apply a bridge to each one of these caps, and we'll add a twist to that bridge. So you can start anywhere on the model, but I'll start right here in front of me, and I'll select one of the new caps that we've just added, and I'll hold down Control to select the other one. All right, then holding down Shift, I'll select my bridge command, and that'll bring up the caddy parameters. All right, so we're going to add, let's say, 3-4 segments, and we'll just give it 1 twist. All right, so 4 segments, and then just 1 in the first twist parameter. All right, and just accept that. All right, now rotate around and select 2 more faces, and hold down Shift, bring up the caddy again. Now it will have retained most of the settings that we used in the previous bridge, except for the twist. For some reason, it does not retain that twist value. Otherwise, we would have just been able to repeat the command all the way around without bringing up the caddy. But for some reason, at least in my version of 3ds Max, which I'm using 2012 here, it does not retain that twist value, so I have to bring up the caddy each time and add the twist again. Okay, so I'm just going to do that all the way around. All right, and still a fairly quick procedure. All right, So adding the twist, and make sure you, when you add the twist, if you have to do it the same way I'm doing it, make sure you're adding the twist in the same direction each time. So you're not giving it a negative value for one and a positive for the other. It should be a positive one for each one of these bridge twists. All right. And then finally these last two. All right, I think that's it. All right, so now we have this object. All right, which is actually a pretty cool object all by itself here. And in certain cases, this might be what you're looking for. Okay, you can harden some of these edges and subdivide it, and it would probably result in a pretty cool object, even for 3D printing. But we're going to go take it a couple steps further anyway. All right. What we're going to do next is we're going to subdivide, but we're not going to use Turbo Smooth because we don't want to subdivide with the and we're not going to use, if you're using 2015 or above, you have the new and improved Open Subdiv subdivision modifier, which is great, but we're not going to use it in this next step. On this next step, we're going to use the traditional Mesh Smooth, and I'll explain why. All right, Mesh Smooth, unlike some of the other subdivision algorithms that 3dsmax carries, comes with a number of methods for subdivision, and by default that will be the NURMS subdivision, which we all know and love, so to speak, but we're not going to use that one. We're going to open up this rollout and we're going to go down to Classic, and Classic is more or less, if you're familiar with Top Mod, you know, the Dusabin or whatever, I think it's called Dusabin or Dusabin subdivision algorithm. And this is basically that algorithm, the same type of algorithm. All right, the classic mode. So we're going to use the classic mode, and over here under the parameters rollout, we're going to increase the relax strength to 1. Okay, so your edge flow should look like this. All right. All right, so now we're going to apply an edit poly on top of that. You can see the modifier stack is getting a little deep here. All right, but that's okay. An edit poly on top of that, and we're going to go ahead and select all the quad faces as well as these central triangular faces. All right, so we can start out like this. We'll select all of these on the outside, and then just rotate around until you could see the interior portion, and select the same face areas on the inside. All right, then go ahead to select similar, and that will grab them in all the corners. Now be careful, because see here, it has inadvertently selected one of these random faces, which we don't want it to do. So you could just go ahead and deselect that if it's done it to you. All right, the first time I went ahead and did this, it didn't do that, so I'm finding it peculiar that it's gone and done that now. But the reason for that is probably because these particular polygons were exactly the same as the ones that I've intended to select. All right, usually select similar is very intuitive, and you might not have this problem depending on your scene scale and whatnot. All right, so just make sure that those random faces that it may have grabbed are deselected. So all you want basically are these 3 quads and a triangle in the middle on each corner, inside and out. Okay, and then once you are confident that you have everything you need selected, hold down Alt and tap the L key to loop that face selection. All right, so it should look like this now. Okay, and just roll around and make sure that everything is selected appropriately, in which it is in this case. All right, now Control I to invert the selection, and go ahead and just delete those faces after you've inverted. Alright, so now that leaves us with this ribbon-like structure. Alright, and that's what we want at this point. Alright, so our next step is going to be to just add a relax modifier on top of that. Now make sure that all faces are selected on the face level beneath that, and then add a relax modifier on top. And deselect the keep boundary points fixed, which is selected by default. Deselect that and give it 1 or 2 iterations. Okay. It all depends on how thick you want your object, although you could adjust the thickness later. This helps to smooth the edges. Okay, so you know, the only consequence to that, the only side effect to that, is that it does thin the polygons the more the iterations you give it. Looking on you know, the 1 iteration is okay, but I'm going to give it 2 iterations because we'll fix that thinness in the next steps. All right, so this is the object now. All right, so what we'll do is we'll go ahead and fix that thinness. We'll add another edit poly on top of the relax. Go into face mode, and they should all be selected still. All right, if they're not, go ahead and select all. Control A to select all. And in the graphite ribbon again, under the polygon rollout, click the little arrow and bring the drop-down box, and go ahead and hold down Shift while you select Outline to bring up the caddy. And this is a nice little tool here, the Outline tool. And what that does is it gives the selected polygons more surface area. Alright, so we're going to give it a surface area probably of around between 1 and 2 millimeters. So let's say 1.0. Alright, 1.0 looks pretty good. I might even go a little higher than that. I might go 1.5. Alright, and I'll accept that. Okay, so then we've brought back some of that surface area to these polygons after the relax, and they're still nice and smooth around the corners because of the relax that we've applied. So, all right, so this is the object. We're almost done now. Again, this is the result we're looking for, this intertwined tetrahedron. All right, so from here we can go ahead and let's see, we're going to apply a shell. Alright, you don't need to keep anything selected there. You can apply the shell. Now it's going to retain the parameters from the previous shell. You don't want that. Alright, we're not going to use the inner amount. We're going to use only the outer amount. Alright, so you're going to notice now, let me zoom in here. This may or may not happen depending on how many iterations of relax you've used, or you know, different scenarios, but I'll show you what could happen here. Now we're going to increase the outer amount, and this is if you're going to 3D print it. You would I use Shapeways for my 3D printing. I think they're the best for these kind of objects. The thing is that you know, if you want a minimum thickness for certain materials, you know, there is a minimum wall thickness or whatnot. So, you know, I like to go in this kind of object. I might go between 1 and 2 millimeters, but you may even want it thicker than that. But you'll notice what's happening here when we increase the outer amount. We're having a problem in this corner, and in all the corners that are like this one, of the edges start to cross. Okay. And that's just a result of pushing these faces out along their normals, and it's going to eventually cross edges. Alright, now that's okay if you want to keep it, say, at just 1 millimeter thickness, but in this case we're going to go a lot more than that, so we're going to need to adjust something here to keep it from crossing. Alright, and the way to do that is we'll go back down to the Edit Poly level, and we'll go to Edge Mode, deselect everything, and then actually we'll go to vertex mode, I'm sorry. Alright, and what we'll do is we will select these two vertices right here that initiate the crossing effect when the shell is applied. Alright, and we'll select those two. We'll go to our modify and select similar, and that should have, with any luck, yeah, alright, it's selected those same vertices in all of the problem areas around the object. Alright, so now with all of those selected, we're just going to tap collapse, use collapse, and that will collapse them together. Alright, then we'll go ahead up here and we'll select the two vertices above the one we just collapsed, alright, that make up this new triangle. And we'll select similar again to grab them all, and we'll go ahead and collapse those. Alright, now what that has done is given us a single edge here instead of the two edges close together. Alright, and that will help us now when we go up to our shell. We can increase that shell a lot more, and it will not cross those edges. Alright, and so it's looking good now. So we could shell that out to even about 3 millimeters. Alright, and we don't have to worry about it crossing those edges. We can even go further than 3 millimeters. Alright, so nothing is overlapping. It's looking pretty good. Alright, so now this is it. Basically, what we can do next is just go ahead and apply either a turbo smooth, or if you're using a newer version of 3dsmax, go ahead and use open subdiv, which is a fantastic subdivision surface modifier with a lot more options. Alright, and this is the result. Now if you wanted something thicker than this, alright, I think in my example here I squared off these edges a little bit more, and the way I did that was very simple. I would apply another edit poly above the shell modifier, then go ahead and collapse 2 to make it into an editable poly object. And the reason for that is because when it's an editable poly object, actually before I do that, let me Control Z that. In my shell modifier, I'll go ahead and select the border edges there. Alright, then I'll go ahead and collapse 2. The editable poly object has the crease edge feature. Newer versions of Max, you'll have a crease edge modifier, which will work excellently with the new open subdiv. But in this case, I'm using turbo smooth, so I'm going to use the old-fashioned crease, which is a little not as slick, not as good as the new one, but it works nonetheless. Well, it seems I lost all of my internal selections here, so I could just go ahead and select these manually. Alright, I'll just select these edges manually since I lost the face selection that I wanted. Okay, and this is just to show you how you could apply a little bit of a different effect to it, really. It's not necessarily that you need to do this for the tutorial. But we'll just go ahead and select those edge loops, ring them until we have all of them. So now I'll just increase the crease parameters under the edit edge option, and I could go and look at this, look at and show end result, and just judge where I want to crease that. Again, this is not as a clean crease as the newer algorithms are, but it works fine for 3D printing, stuff like that. So I'll give it a little crease of about maybe 0.3 I mean. Alright, and that's it. Click F4 to get rid of the edged faces, and I'll give it maybe 2 or 3 iterations if I'm going to export this as an STL for printing. And this is the object. Now, what you can also do to finish this off, if you wanted to, get some thicker result here, just apply a push modifier on top of the stack and you could push it out even thicker. Just be careful not to overlap. And also, if you're going to 3D print, be careful of the distance between your joints here, or your struts, not to come so close as to cause it to have trouble printing. Alright, so just be mindful of the tolerance space that your 3D printer will have. In the case of shapeways, you can go pretty thick and come pretty close. It's very accurate. So, alright, so this is the object. There's a lot more you can do with it. You could, if you're just going to use it in a render scenario, you could add different multicolored surfaces to it, or a multi-sub-object material surface, and go crazy with it. Alright, so, but it's a pretty cool looking shape and fairly easy to achieve. Alright, I hope you enjoyed this tutorial. The holidays are coming up. I wish everyone who celebrates the holidays happy holidays, and stay healthy. And thank you so much for your support. Don't forget to like the video if you found it useful. I will be adding this up on my Shapeways store for anyone who may want a 3D print of this object. I'll leave the link in the description. So once again, thank you for watching. Don't forget to like and subscribe, and I will see you again very soon. Hopefully I'll have another video up before the holidays, but if I can't make that deadline, then I will see you immediately after the holidays. Have a great new year, everyone. Bye.